Good morning. I'm Jonathan Peters from the College of Staten Island, which everybody used to say, where is Staten Island? Now everybody says, oh. But I'm happy to be here today. It's great to be here. Dr. King and I are going to present a little bit about the fraud data. Some of you may have seen a little bit of this last year, but we've been looking at the New York City medallion data. For those of you who don't know, the medallion data in New York City, we have 12,533 yellow cabs in New York City. The system that was put in place by Matt Doss was a metering system that includes an online fare record trip, electronic trip sheet, which we have been analyzing using our data systems at Columbia and City University of New York. There's 378 million records in the data set in the past. We are out now at this point in time picking up another 150 million for approximately 500 million trips in the taxi database in about 2.5 years, 3 years worth of data. This is a significant lift. Anybody who's going to get into this game, and I think it's happening in more and more cities, you're going to have a significant data challenge. New York City is quite big, but other cities are going to be also large. The advantage we have is that is a supercomputer. There's actually a few of them. On the right is the Cray, and that is very, very helpful if one has to lift a lot of data. We do a lot of different types of analysis, but basically, New York City is really fascinating as an industry, an area to examine because the market is so diverse in terms of different transit options. We have pretty much every type of transit option and issue you could have. And we also have all sorts of issues related to freight, port commerce. We have issues related to heavy-duty biking, walking, car-free households. So it's a real interesting market to analyze. We also have an extensive amount of tolling in New York City. There are 5 boroughs in New York City. And obviously, when we take the data and look at it, this is 20 million observations of data from the taxi cab data. The green is the origin data. The red is the destination data. And you'll notice that the origin data is somewhat more clustered towards the center of the city of Manhattan. And some of it, the red is a little bit more diverse. The users want to go further out. There are a lot of origins in Manhattan, but you can't see them because they're overlaid by the destinations. Origins overlay them. So we're going to talk today a little bit about fraud in taxi cabs. We've been looking at the data in different ways, and one of the things we decided to look at was fraud. And one of the questions is, can you identify fraud using the GPS data? Well, obviously, again, Ray and we've already talked about, Roger talked about issues related to fraud. I'm not going to tell you a tremendous amount, but obviously it's important to keeping your system honest. It's important to keeping support for your existing operators in your area. If there's a perception of fraud, I think that will undermine the political support for the existing system. And obviously, it's an important part of the regional transportation network, so it should function well. And so one of the things, and Dave King and I have been talking about this, and Dave emphasized that this is a credence good, that your users want to believe that they're getting good and fair value, and they rely on the driver to be honest and appropriate. So a credence good really relies on you to make a decision, much like a doctor. Your doctor tells you what you need to do and also provides you with a service. So obviously the question was, well, how could you deal with fraud? First of all, fraud's been around a long time, and I specialize in tolling systems as my second area of research. And people don't like to pay, so there's fraud on both sides. There's user fraud, and there's also fraud from the operators. And the question is, once you have fraud involved, the first thing you have to do is detect it. You have to see it, and you have to figure it out quickly if you're going to try and catch it. Then once you figure out that it happened, then you have to catch the person. You have to have some sort of interception or policing of the fraud. And then once you catch them, you got to have somebody to punish them. So it's a complex process, and the GPS metering system is giving us an interesting idea of how we might identify fraud, and that's what we're going to talk about today. So Dr. King was in a taxi cab and had a posted sign that had the meter off. The cab going to the airport had the meter off and said, "We like cash transactions." So we're suspicious that obviously this driver, welcome, dear passengers, I really appreciate your cash payments. So this was potentially a fraudulent trip that wouldn't have been caught by the meter, but it shows you that even in the regulated market, it's going on. So again, we thought about how could we identify potentially high likelihood fraud trips, and there's a couple different things. One would be a short trip with a very high fee. Second thing would be a trip that takes a very odd route. Third would be trips that have long travel times and short travel distances. 4 would be trips with long, what we call wheel turning distances, which is actually how far the car travels. And then very short, what we call crow fly, which is a linear distance between the starting point and ending point. And then obviously anytime there's a surcharge or any sort of fee applied, that's an inappropriate time. So these are the things we can all look for. I'm going to talk today just about number 2, which is when you find an odd route. Basically, Manhattan is the dominant area for taxi cabs in New York City, with 80% of the trips happening in Manhattan south of 110th Street. And 50% of the trips happening south of 59th Street. So I'm going to talk about the item 1, which is the top area, which is the main central business district. There's a high concentration of business in that area, and there's also a high concentration of high-income users. So we're going to look for fraud. And what we're going to use is the fact that they have a lot of toll bridges. And if you take a trip in Manhattan and go to another location in Manhattan, there's no reason you should be taking a toll bridge. But some cases, the question is, do any people actually take trips that have a toll flag on them that says, yes, you paid a toll, and yet you started and ended in an area that you shouldn't have to take a toll bridge? So the example is, this is the taxi data for New York City. That's actually about 300,000 observations on that slide, and this is the lower section of Manhattan. These are the origins, and then these are the destinations. Gives you a little feel for how they're spread out a little more. There's the 300,000 origins, 300,000 destinations. And we can overlay them and obviously see a little bit about how the market functions. So we asked this question: if you're going from this part of the city to this part of the city, did anybody take a toll bridge? And the answer is, when you look at the data, this is an example of how it would be. You'd have to start off in the center of this. The hatched area would be the area which they're beginning and ending their trip. So you'd have to go through one of the toll tunnels, like the Brooklyn Battery Tunnel, which all flooded. Everybody knows this. It turned into a drain. That would be an example. The example I gave was the Brooklyn Battery Tunnel, where you go to Brooklyn and then come back. And obviously that would be the classic example of your taxi driver taking you for a ride, right? So if we observe this, and we can actually observe this, we went through the data. So we then pulled through the data, and there's actually origins that went out of the city, went through a toll bridge, and wound back up in Manhattan. We scaled it up a little bit so you can see the data. And there's actually 1,600 trips in a 3 million record sample that actually had that characteristic. And we plotted them out using GPS data, and there they all are, and they're spread all over the city, so they're odd trips, and we have to ask, why are they there? This is the south end, right south of Central Park. And what we did was we actually numbered the trips. So you can actually see the origin is blue and the destination is red. And we circled some of them, like 726 there on the far left. That's a trip that began and ended close to its origin point. It wasn't exactly the same point, but it was close. The one that's circled, 285 over there, that began and ended exactly at the same data point. So we're going through the data to try and figure out whether or not it's data errors, which looks like 285 may be a data error, and 726 might be someone doing a round trip. Now, there are ones that are really strange, which is 48. 48 has an origin over there on the far right, and it ends over here on the far left, that's a very, really short trip linearly. I'm suspicious that person got taken for a ride. So it's interesting because the data has different types of error, 852 as well. Somebody was on the east side and wound up on the west side and went through a toll bridge. I'd like to figure out how that happened. We also looked at the village, which is a more residential area. You do have the same kind of patterns, sometimes ones that are similar and sometimes ones that are somewhat spread apart. And we actually did a comparison of the actual average trip length surcharge. This, again, gives you some of the depth of how the data can be analyzed. We compared the toll trips versus the non-toll trips, and then did a test of whether or not they're actually different. And the answer is yes. The one I want to point out for you is the fare per mile is radically different, which is the average fare per mile, $6.31 a mile. For the toll trips, it's $84 a mile. Very short trip, very high fare. And the other thing that's really interesting about it, again, is the total cost of the trip. The trip on an average New York City, Manhattan to Manhattan destination is $8.40. The toll trips are $38. So there is some indication here that something very, very strange going on. And by the way, we tested it. Yes, they are different. On the right, almost every characteristic except number of passengers is different in the data. Now, again, this is not an absolute, answer or result in terms of finding fraud, but I think it's useful. It shows you some of the ideas. How big is this problem? Well, it's 304 trips per day based upon our sample. That means 110,000 trips would look like these strange trips per year in New York City. That would be a $22 difference per trip, or $2.5 million in fraud potentially occurring, or strange trips occurring. Now, I'm not absolutely saying this is the amount of fraud with this type of characteristic, but you as a regulator don't want to have the situation crop up where something goes on and it gets into, it becomes a scandal. This might help you flag stuff early. You can take a look at your data and start to understand whether or not people are contributing to odd trips. The key thing I would say is it might help you identify drivers with a problem. So for instance, you can look at the trip time on the vertical axis and the distance. So in the square box are trips you might want to examine. Not that you'd always say that this is a fraud trip, but if you have one driver or a small group of drivers that are always having these long travel time trips with very short distances, you might want to ask them questions and watch them. Same thing you could look at, you can plot your data and look for identifying where you have a lot of trips that have high cost and relatively short time. Same thing, you might want to look at areas that have high cost and short distances. These are all things you can mechanically code into your fare box or your metering system to flag out to you for further analysis. And I'm not saying definitively it gives you right off the fraud, but you would see drivers. If somebody's always popping up in one of these boxes, I think you might want to start asking some questions. And better you ask the questions, by the way, than somebody else. The other thing we actually found in the data, which is pretty fun and it's pretty interesting to see, is that there's people operating outside the actual reported operating characteristics of the New York City taxi cab system. In particular, we found 360,000 trips a year occurring in New Jersey, across the river, in Hoboken, Jersey City, and other areas. And it's a combination of both destinations, which are actually fine, you know, because it's A-OK. By the way, this was reported in the New York Daily News back in July. But it's okay to drop people off in New Jersey. That's acceptable, this is right across the river from Manhattan. It's A-OK to drop people off. The Jersey City regulators and the Hoboken regulators wouldn't generally like New York City taxi cabs to be picking up, and apparently they are. And again, it's not a few trips, it's a lot of trips. So again, this is an example of how the GPS tracking data can really provide you with some insight into what's happening in your marketplace. I think it offers you a lot of opportunity. And obviously, we can look for things like odd behavior, and these may help enhance the understanding of whether or not you're keeping your market running well. You can put together a mechanical evaluation. We can think about ways we could easily put together some sort of electronic evaluation of your data to look for the odd trips, and then look at those drivers and see whether or not they have odd behavior. We do not have, the TLC in New York City did not give us the drivers, so I can't tell you if I have a driver pattern, but I can tell you I see a lot of odd trips. And obviously, we had that data. We can then look at cab companies that may have odd practices or drivers that may have odd practices. And obviously, this can be the root of deeper fraud analysis in the industry.